Okay, hello. For the ME405 design project, our team, which we are calling Lemon Launch, has developed a possible solution that we think will benefit the end users of our product, that being, of course, schools and education systems. And the way our team structures, how we approach this problem, is first of all, we divided our team of 10 people into three separate groups. First of all was the design team. And what the design team is, they came up with a valid design that worked and met the specifications, and that we thought would appropriately demonstrate how this uh, project contributes to the education of uh, people younger than us, sixth formers, college students, so on and so forth. And secondly, there was, of course, the calculations team to verify and check over everything that the design team did, and were in constant communication with the design team. And what the calculations team were mostly focusing on were the validity of our design, uh, and making sure that everything's up to scratch. And then, of course, we had the website and branding team, which is for marketing our product mostly. All right. And as the leader of the design team, I was responsible for mostly giving ideas for how our design could approach this particular problem. I came up with several nose cone ideas because our design, of course, needs to be aerodynamic. And I varied these nose cone ideas slightly differently with each one. Like some would be longer and some would be shorter. Some would have a different slope. Some would be pointy. Some would be blunt at the top. And what we found is that the blunt tip and with a short overall length is superior to the other design.
So I designed the fins. I made various models of them with different airfoils and sizes, and I seem to have come to a good midpoint between the two. It works quite well. It's aerodynamic. It's good. We use NACA 0008. It's connected to the fin can with dowel joints. So
So my role in the design team was to actually kind of like refine the final product. Once I finally received the nose cones from Alexi and the fins from Arthur, I assembled a sleeve that kind of attaches the fins onto the rocket itself, because we didn't necessarily have a way of putting the fins onto the rocket without making it wonky and stuff like that. Besides that, I had done a few flow simulations to see if the flow was separating, if it was going over the fins, and if everything was working in order. Refined the model a bunch of times every time we had a meeting. Once that was done, we had like a final design, which I sent over to Ulrich after a bit, so he could look over it and see if everything was all right. And yeah, that's pretty much what my job was.
Hi, my name's Aldrich Fernandez, and I was in charge of overlooking the CAD team, and I basically did all the quality control, and I basically looked at the CAD designs and made sure that they were perfect before sending them off to like the website design team and to the calculation teams as well. Um, I was overlooking the CAD team as I had previous experience in SolidWorks from college.
My name is James, and I was in charge of the calculations team. Our team basically went through, and whatever the design team was doing, we helped them with. So initially, we had several designs when we were deciding what we were going to do for the nose fin, etc. But we helped to cut them down to the final design we were using. We also did several things like reviewing them with the design process with them, going through the labs and stuff. With that, we talked about by my other colleagues. Overall, we kind of helped out the design team whenever we could, and also lended assistance to them in what they were doing as well as what we were doing as well.
Good morning, everyone. My name is Professor Samal, and I'm very excited to share our material selection process for our rocket powered water powered rocket. And for this, our aim was very simple: find a material that is lightweight, easy to manufacture, and safe and durable under our flight condition. So for this, we had options from 5 different common materials. They were like ABS, nylon, polycarbonates, and PLA. And for both fins and notes, PLA stood out the most because it was lightweight, durable, ease of manufacture, and stiff as well.
Martin Sanusi, and I'm part of the calculations team. Initially, I was working with progression, figuring out what materials to use for the rocket, as we wanted to maximize our results. I also looked into a bit of flow simulation, but mainly I'm in charge of the microbit, and I was able to learn a lot from the microbit since it was a way of like coding or a bit of a fun way. So I was able to like build a bit of confidence when I was trying to make the microbit. Two microbits, the relay one and the onboard microbit. They both have different codes to them. So I was trying to most of the time I was trying to hack the code, but it was easy along the time. It was easy most of the time, but I just didn't know my way around the one concept. But ever since then, I was able to have fun with it and understand how it works. I'm going to use it to find the acceleration of the water rocket.
Okay, so I'm Pablo, and as a part of the calculations teams, I was in charge of doing the labs and looking for the most appropriate designs and rates of water and air pressure in the different models of the rockets. I was also in charge of the risk assessment, where I had to look for the possible risk not only during the lab and the assembly, but also during the rocket day to ensure everyone's security in the moment of the launch.
Hello, I'm Sam, and I'm part of the communications and marketing team. It was our role to create a brand identity for our product, including logo, visuals.
Hello, I'm Krishna, and even I am the part of the communications and marketing group. We basically made a website that showcases our project, including all the specifications, the design, and the product itself.
We worked closely with both the calculations team and the design team to make sure we had accurate values from the SolidWorks fluid simulations and pressure testing, as well as a log history of all different designs from day one.
We have created a website for our product called the Lemon Launcher. So I will be talking about the specifications first. In our specifications tab, we have information about the key features like the dimensions, the water capacity, maximum pressure, the flight time, things like that. We have information on the component measurements like the fin, peg, and bottle respectively, and different rocket comparisons as well in terms of the cones. We do have information on performance specifications and safety features. We had to identify a material that provides high stiffness, low density, excellent dimensional accuracy, and reliable 3D printability. So we have created a table that shows key properties, and the value have been gathered from the aerospace material databases and published literature. I will also be talking about our team. Our team consists of the design team, research team, and communications and marketing team, and have information on who's the lead and what the key contributions of each person and the team are, respectively. We have also created a project timeline and progress chart, also called a Gantt chart, that talks about our key milestones, like from creating a website to actually testing the model.
Hello and welcome back to the Lemon Launcher. I'll be going through the rest of the website with you. So Krishna introduced you to the team and the specifications tabs. Here we have the introduction tab, which shows a poster for our project, and the project video, which will be coming as soon as I've recorded this segment. We also have the designs page, which shows all assembly drawings and part drawings of the rockets from SolidWorks in PDF format. These can be viewed on all devices. We also have different fin designs and cone designs shown to you here, as well as a video of the 3D printing process and evidence of the fluid dynamics testing in SolidWorks. As well as the design page, we also have a try it yourself page, in which you are able to download the SolidWorks files as well as all of the microbit files, just showing that you are able to download all of these so users can use it themselves. And on top of this, we have information about the microbit, as well as an assembly guide and safety instructions for any person that is willing to download this and use it for themselves. We also have a testing page which shows all results from the volume and pressure testing optimization, the thrust testing, the best volume of water, and pressures, printing time, development time, and test results showing the Y offset and the X offset for the pressure testing done by the calculations team. And finally, we have the appendix. This shows the product design specification, all of the steps involved, and importantly, the risk assessment carried out by the calculations team as well, which shows all possible risks involved in this process. Thank you very much.